So this next one, we get this form. We get 0 times infinity when we do this one. Okay, well we plug in the 0. And do you guys know why it's 0 coming from the positive side?
It's coming from the right side.
It has to do with one of these functions.
With the asymptote?
Yeah, it's because of the asymptote. If you look at, if you guys look at natural log, it goes like this. Natural log of x goes like that. And so you will not have any negative x values. So let's take a look at this. If I plug in 0, let's see what we would get. If I plug in 0 to test it, I would get 0 times, and then if I plug in 0 to this, actually, can I plug a 0 into natural log? I mean, this is actually not allowed. This should hurt some of your eyes. You cannot plug a 0 into that. It's impossible. You can't plug a 0 into a natural log. However, we are doing a limit. We're not actually plugging it in. We just plug it in because that's kind of like the trick. But if I was approaching 0, what would my natural log function be approaching? Negative infinity. Okay, it doesn't even matter if it's negative or positive infinity. We could just put infinity right here. Okay, so we got it in this form. 0 times infinity. I want to use L'Hopital's rule because it's so simple, clean, and pretty. But I can't. I can't use it right now when it's in this form. Because in order to use L'Hopital's rule, you have to have a function being divided by another function. You have to have a quotient of functions. And so since we're pretty clever in here, is there a different way to write x times the natural log of x as a quotient?
1 over x over 1 times.
You just write the derivative?
You can write it like this. The limit as x approaches 0 from positive, you can write it as natural log of x on top and x to the negative 1 on the bottom. How do you guys thought that? Yeah? Did you? Did you? Did you think it?
I see what you did.
Yeah, you see what I did right there? I just took I took the x, since it has an exponent of 1, and I dropped him. I took this guy and put him down here. And what does that do to the exponent when you change its location on the fraction? It changes the exponent to a negative. And so it was positive, now it's negative because I dropped him down. But now I have a quotient of 2 functions. When I have a quotient of 2 functions, now I can use L'Hopital's rule. Yay. So let's take the derivative of the top and the derivative of the bottom and see what happens. What is the derivative of the natural log of x?
1 over x.
So I have 1 over x. And then it's being divided by, that would be negative 1x to the negative 2, right? Okay, now I'm going to rewrite this so we can see it a different way. We have 1 over x, and this is going to be negative 1 over x squared. You guys with me on that one? Do you guys see how I got that?
Yeah.
Okay, and I did that so I can get to this part. Now, some of you guys might have skipped straight to this part. We have 1 over x times the reciprocal, because instead of dividing, I'm going to multiply by the reciprocal. What's the reciprocal of 1 over x squared? X squared over 1, and it's still negative, right? Yes. Okay, when I simplify this, I get negative x. All right. So if I take the limit of this function as x approaches 0 from the positive side of negative x, what would I get? 0. That's your answer. Now, again, I'm visual. I want to make sure I'm right. So I'm going to look over at a graph to see what this looks like. Okay, so let's see. Let's get rid of that. We'll go over to my graph. Where are you, graph? You're somewhere around here. There you are. Okay, here's my graph. I already have it punched in for us. Look at that. As we approach 0 from the right-hand side, we approach the y value of 0. It's undefined at that point, but it is approaching 0. There's our function right there, so on and so forth. Okay, questions? Oh yeah, wait, there was one more thing I wanted to show you guys. Sorry. And that is, that's this. Okay, this is like the formal definition of L'Hopital's rule. Check it out. Assume that f of x and g of x are differentiable on an open interval containing a and that. Now, a is the limit, what you're approaching right there. Okay, so containing a. Now, if f of a and g of a equals 0, that in other words, if you get 0 over 0 when you plug it in, you will also assume that g prime of x will not equal 0, which makes sense. You don't want this to be 0 down here when you take the derivative of it, except if you plug in a. But anyways, you got to assume that this will not equal 0. Then you can use this. If you get 0 over 0, you can just take the derivative of f and g and find the limit of that. Those equal each other. This down here is showing you if you have infinity over infinity, you can do the same thing. Okay, so these are the two important things. Remember I told you guys earlier that you have to have in order to use L'Hopital's rule. If you do not have these things and you do L'Hopital's rule, you get a wrong answer. You get a different limit and it is not correct. Tomorrow we'll look at why.